Alright, for our lab we decided to show what forces look like and how we can see them on a very basic example. So here we have what our lab's going to be. We'll talk about that later. But for now, we have a simple coin. We know that wherever we stand on Earth, or if we're around Earth, there's a gravitational force. The gravitational force is just the force that the Earth applies on us and pulls us towards the center. We can simply see that just with a simple coin. The coin we've seen in the demonstration, but a coin. We have the coin here, and if I drop it, we see that the force of gravity pulls it towards my other hand. Pretty simple. But let's take this and put it on the counter. We know that the force of gravity is acting upon it still, but somehow it's not going through the table just because something's in the way. So what is this? The force of gravity is pulling it down, but the table itself is pulling or acting in an equal and opposite direction, with the normal force pushing upwards. Which is very, very cool because that's what prevents that from falling through. But let's take that a step further. So we've explained the very first part of the lab where we're going to put this on top here. We now have the force of gravity acting down, and the force of the cue card is applying upwards here. So it's just the same as doing this. Now for the fun part. We're going to keep with the cue card, and we're going to describe applied force and frictional forces. A frictional force is, if we look at the table here, if I come in from the side and I say I want to push this table, initially the static force is the force that I have to overcome to get the table to move just a little bit. My applied force has to be greater than that static force in order for me to push the table. Now if we take the coin, put it back on top of the cup here, pardon me, we'll put the cup here, cue card on top, coin on top of that. So it's just a simple little setup like that. If I grab the side of the cue card like this, but mind you, if I put it on top of the coin, where I now have the gravitational force pushing downwards, normal force pushing upwards from the cue card, we'll say that me applying the force in this direction is the force applied in this direction. Static friction is in the opposite direction. If I grab the cue card here and I apply my applied force with a hard enough jolt, I will be able to have the coin fall into the glass simply by going like that. So let's look at the same lab again. It's the same thing with the cup, the cue card, and the coin. But let's step this up a little bit. It is Easter time, so we're going to take the coin out. We're going to put it on top of the bigger glass. We're going to step it up here. And instead of a coin, we're going to have an Easter bunny chocolate. Why not? So, same physics are applying here, where we have the gravitational force applied downwards onto the cue card from the Easter egg. But again, the cue card is preventing the bunny from falling into the cup. Okay, so what does that mean? The normal force is moving upwards. Again, we have the static force, or the static friction, which is the same thing as me pushing on the table. And we have the applied force I'm going to apply. So it's very, very same lab, only a little bit different, a little bit bigger. You can see it a lot easier, and it's a little bit more fun because it is the Easter time. So same thing, my applied force has to overcome the static force. I won't move it because I'll knock it over, but I'll move this fast enough and the chocolate bunny will fall inside. It's just as simple as 1, 2, 3, inside. And that's all.